Hello, this is a quick video just to illustrate some of the uses of class variables and class methods in Java. So first of all, before I talk about class variables, I'm going to talk about instance variables. Now, whenever we create a class up to now, we've introduced some attributes or some fields. Now, the proper word for those are instance variables. They are created whenever an instance of the class is created. So if you have something like class 1, now I've made this quite compact, but we have the class name itself, beginning with letters capital C. We have a single field, var1, which is private, and then the constructor, class 1, takes a single parameter, v1, and it assigns v1 to var1, and then we've got some other methods if we want. So if we ran this thing and we created some instances of the class, what happens is memory is created for the objects and for all the fields which are contained within the objects. So for example, if we created a new instance of class 1 called A and passed over the parameter 5, then A would be declared in memory, and a pointer would be declared or a reference to another part of memory where all the information about the object was stored, for example var1 and its value 5. Similarly for B, if we declared that with -8, a different instance variable for var1 with a different value would be created in a different bit of memory. Okay, so that's instance variables. How do class variables differ? Well, we can also declare variables with the keyword static. Now, if we do that, then that variable then becomes shared by all objects in that class. So for example, var2 here, it's been set to the value 0, and I've used var2 in the constructor, but I'll come back to that in a moment. If we wanted to access that class variable, I could do that without having to create an instance. That's why they're not called instance variables, they're called class variables. And we use the name of the class as a receiver. So for example, system.out.println class1.var. So here we know it's the name of a class because it begins with an uppercase letter, and if we ran that, it would return 0. But we could also create an instance of the class, so A, and then we could print out a.var2. This time it would return 1. Why would it return 1? Well, there's only one copy of this thing, of var2. It had the value 0 to start with, but when we created a new version of class 1 with the constructor, what happens? var2 had 1, it was incremented, had 1 added onto it. So that meant that var2 now stores the value 1, and if we referred to var2 using the class name, it would store the value 1 as well. So we've changed the value.
It's 20 hours.
There's only one copy of it actually stored in memory. Now how we can actually represent that with the following little diagram. So creating creating A now creates a part of memory which is to store the object, but also there's a common part of memory that A can reference where a class variable is stored, and that's set to 1 because we've added 1 onto var2 when we created a new version of class 1. When we create another version of class 1, what will happen is we save a little bit of memory to store the object B, but also var2 has 1 added onto it. And now if you referred to var2 either from A or B, it would have the value 2. Similarly, we can declare static methods. Now, an example of this is if we had a class called class 2, we could declare this method here called product as static, and that would mean that we wouldn't actually have to create an object of type class 2 in order to run that method. So class 2, that's a class name, dot product 34 would return the value 12 without having to actually create an instance of class 2. And we'd be doing this a lot because every time we've used a main method, we haven't created an instance of a class, we've just run the thing. Okay, so let's have a look at how we can do that in practice. So here I've got, I've already created a main method, and so the main method's there, it doesn't have anything in it, and a test class. So within this test class, what I'm going to do is I'm going to create the usual sort of private int instance variable. So I've got a field called instance variable, and I'm going to create a public class variable, public so that we can access it from outside. There's only one version of it, and that's going to be called class var. Now I'm going to set that to 0 to start off with. Now if I go back to the main method, I can actually already, if I use the class name, I can already get or access the class variable. And if I run that, it should come up with 0. So that's accessing the variable through the test class. What else I can do is I can create. Let's create a constructor. And if I try to create a constructor, it will only actually allow me to use the instance variable in the constructor. And I'm going to create some getters and setters. And if you create getters and setters for all the things, you'll find that the getter and setter for the instance variables are as before, but the ones for the class variables are actually static. You can't do anything with a static variable or class variable in a non-static context, so that's why they're static. So now if I go back to my main Java class, I can do test class dot. Now this should be, yeah, I've got two static methods that I can do, so I can run set class to 3, so that sets the class variable, and then if I do sout test class dot class variable, then I should find that that now has been set to 3. I haven't actually created an instance of an object yet, but I can do that as well. You can mix these things about, so I can create a new instance of test class and instance value 9, and if I run this, sorry, if I do sout, I can actually do t dot class var. It doesn't like this though. I'll get a warning when I do this, and the warning, well, I'll run it and you'll see that you do get 3 again, but the warning says that you shouldn't really access the static variable using the object. You should access it using the class. So there's no difference there. But what I can do is within here I can do test class dot class var plus, and now if I run this thing, class var will be set to 0, then it'll be set to 3, and when I create this thing it should change it to 4. There we go. So doing that sort of thing, having a static variable and in the constructor incrementing it, means that you've got a common count of how many of this type of object have been created. So that's one of the common uses of static variables. But you'll see other ones, in fact, one of all of the maths libraries, sout things like math dot square root, they're all static. They're all static methods, and you'll find math.py, and if you do math dot, you'll see all of the things. So you can see that these are all static. They've got the line through the methods to say that they're static. Okay, that'll do us.